we did this and we did a lot of this by hand. What I'd like for you to do, I forgot to tell you, grab a calculator real quick. I want to show you how to do some of this in the calculator. So grab your calculator. I'm going to do a couple problems here that we did on Friday, but I'm going to show you how to do those in the calculator as well. Okay? And so the first equation that we did is we had this one right here. Okay? We have a linear problem here. F of x equals negative 1/2 x plus 3 has this, and the application that we talked about on Friday in the video is that the area underneath that curve or that line, that function to the x-axis is the integral of that. Now I gave a boundary, I gave a lower boundary of 1 and an upper boundary of 4, so we're now talking about definite integrals, and I'm going to show you how to do this from the calculator as well. So if you take this, and let's go plug that equation into the calculator. So I'm going to start fresh. I'm going to go on. I'm going to go new. And I'm going to not save any of that. I'm going to go add a graph. The graph that I want to add is negative. I'm going to do controlled division so I can do the 1/2 x plus 3. All right? So there is that linear function that we have on that picture that we were looking at on the previous page. Okay. On this, I could find the area underneath the curve in a lot of different spots. All right. But specifically, it told me to find it from 1 to 4. So what I'm going to do is I'm going to go to Menu. I'm going to go to Analyze Graph. That's where most of the work takes place. And if you notice, we do have an integral key number 6. All right. So that's what we've been talking about. So I'm going to select 6. I can take my boundary and I can move it left and right, but that's not super accurate. And so I can just take and type what I want. The lower bound that I want is 1. So I'm going to type a 1 and I'm going to hit enter. So it marks it. Then I can slide that if I want, but I'm going to type in 4 and hit enter for my upper bound. And then it draws a picture of what I have on the screen and it tells me what that area is. So that area is 5 1/4 is what that was. Okay, so I could see a picture of that as we go. Okay, so that's the technological part of doing what we did on Friday. Let's do another one. So if I were to do another one, I'm going to go start fresh. The reason I do, actually, let's see if it'll work this way. I'm going to go to Tab, and I'm going to go back up here, and I'm going to delete this out. Okay. The next one that we had in our notes from Friday that I want to work with you, because it looks a little bit different, looks a little bit weird, is this one right here. All right. This is a circle. All right. I know that I can prove that because the radius is 4 here, the radius is 4 here, the radius is 4 there. So it's a circle, but it's a semicircle, only half of it. All right. But there's my function, the square root of 16 minus x squared. So if I were to go put that in, so the square root of 16 minus x squared, if I were to do that, it gives me that semicircle, but it also didn't give me the right answer, and you can see by the shading it's not correct, all right? So I just applied what I had previously. So if I want to change that, I'm going to go back to Menu, I'm going to go to Analyze Graph, I'm going to go to Integral, and it's going to give me a chance to re-put my boundaries in. So -4 is my lower boundary, +4 is my upper boundary, and when I do that, did your 8.61 disappear or is it still there? It's still there, sorry. And so, but the 25.1 is the actual answer on that. That's the one reason that I said I did in the other class, we just started fresh, all right? Because it won't have that 8.6 on there, it just had the 25.1, okay? Yes, ma'am? The integral is the antiderivative. They're the same thing, all right? But the application of an integral is it's the area underneath that function to the x-axis. Okay, so that's an application of an integral. All right? Good? So we're just going backwards is what we're doing. Okay? All right. So that being said, now we're going to do a little bit more of what the calculator just did there by hand, all right? Because that's calculator part. I need to show you how they're getting that by hand. We'll do that over the next couple days. For today, I want to look at a couple properties, all right? So these properties right here, this is not what I had you write down a while ago, all right? You can take a picture of this if you'd like, or this is on page 448 in your book, Okay? So this is page 448 in your book if you want to reference that instead of writing all of it down. So I'm going to walk you through a couple of properties here as we go. All right? So some of the properties of these integrals. So I have a boundary, a to b, so it's a definite integral. I have a k, which is a constant in front of f of x. So if I have a k, for instance, let's say if I had 2x squared, all right? So I could take that 2 and I could put it out in front of the integral and I could just do x squared here and take the antiderivative of it, all right? So that constant rule, I can leave it there. Sometimes I don't like to do that. I'd rather put it out front, know that it's there, and then do this work here, okay? The next one is adding and subtracting. And so if I'm adding and subtracting functions that have the same boundaries, so they can't have different boundaries, they have to start in the same spot. I could have f of x plus g of x, or I could have f of x minus g of x, and I would find the area of one plus the area of the other, or subtract, depending on what it says. Okay? The next one. The answer for this one is 0. But I need you to look at the integral. What did they do?
They use the same 2 in beginning.
Okay, my beginning and ending is the same number. So have I really gone anywhere?
No.
I haven't gone anywhere. So therefore my width is 0, all right? So my area is 0. So I haven't traveled anywhere, so it's 0. Yes, sir.
If it's like negative 1 to 1, does it include those 2 numbers, or is it anything inside of it?
Yeah, it would have everything inside.
But would it include like the number itself, like 1?
Yes, it includes itself. So they're equal to. All right. On this one, we have the a and the b, and then over here we have a and b, so they have switched. If I change the direction that I do my integral, then it presents a negative in the problem here. Okay? So it's like I'm working backwards, all right? And so we'll see some context of that later, but that's the property on that. The last one that we have here is referred to as the transitive property, or kind of like the transitive property from algebra. But if I go from A to B, if I go to A from B, if I throw a point in between A and B of C, so if I had a stop or resting point, so if I went to A to C, stopped for a little bit, then picked up and went from C to B, that would be the same thing as if I just went from A to B altogether. Okay? So if I go A to B, go part of the way, then it goes C to B, or excuse me, A to C, that's part of the way. C to B is the rest of the way. If I added those two things together, it'd be the same thing as going from A to B in one trip. Okay? So that's kind of what's going on there. All right? So I had you before, as a warm-up, write these down. All right? Now we're going to work through these and we're going to use these properties. Okay? All right. So the first one, I have f of x. Actually, let me go up here. I have f of x and I'm going from 0 to 3. So on that definite integral, my answer is 5. The thing is about this, I don't really know what the shape of f of x is, but I know the area is 5. Okay? It could be a circle, rectangle, triangle, whatever. Okay? The same f of x, but I'm going from 3 to 4. That area is 2. I change functions from g of x is 0 to 3, and it's negative. So what might that indicate from what we talked about on Friday? If I have an area that's negative?
It's below.
It's below the x-axis, okay? So this, the most part of this one is below the x-axis, okay? Then I'll go from 0 to 6, and it's equal to 10. So these two are the same function, these two are the same function, got different boundaries, all right? So let's take off, and let's see what we can do here. So on this one, on question A, it says I'm going from 0 to 3, I'm doing f of x, and I'm doing g of x, but I do have a 2 in front of the f of x, all right? So with this 2 in front of the f of x, that was the first property that we had a while ago. We could put the 2 out front, and we could do 0 to 3 f of x. The g of x, I'm not going to change, all right? I'm going to go 0 to 3, g of x, d of x. I just used two properties here. One property stated that I could take the 2, the constant, and I could put it out front. The other property stated that if I have an addition, I don't have to have it all together. I could put it in its 2 integrals. all right? Now, why would I do that? Well, do I know what this value is right here? It's 5. That's the one thing that they gave me there. That's the given. So in this box, that's 5. Bless you. So I have 2 times 5 here, which would be 10. Okay? In this one right here, this matches that one right there exactly. All right? So this box right there would be -6. So I would say 10 and -6. So the value of this right here would be 4.
That's the answer.
That is the answer. I'm doing all this based off of properties. I don't even really know what the picture looks like. Okay? But if I were to add those two together, that's what I would have. Okay? All right. Let's try the next one. On B, I'm only looking at f of x, and I'm looking at it from 0 to 4. Did they give me from 0 to 4? No, what did they give me? 0 to 3 and then 3 to 4. So basically what we could do is this is the last property that we just talked about. We could go from 0 to 3 and from 3 to 4, and that would equal the same thing if I just went all in one trip. Okay? So 0 to 3 plus 3 to 4 would equal 0 to 4. All right? Well, what's 0 to 3? That's 5. What's 3 to 4? 2. So the answer on that one would be 7.
I like the.
Okay? All right. Everybody okay so far?
Yes, sir.
C is kind of weird. All right? Take a look at the first part of C. What do you notice on that one?
The first part is
3 to 3, so it's equal to 0. So I haven't moved anywhere on this one. So no area's taken place because I haven't moved. I went from 3 to 3. Okay? What do you notice about this one?
It's backward.
It's backwards. All right? So there should be a -1 involved here. There should be a negative of whatever 3 to 4 is. Well, 3 to 4 is 2. So I'm going to do a negative of that. So -2. So the 0 and the -2 would give me -2. Okay? All right? Okay. All right. Anybody still using this right here? I'm going to erase this because I'm going to put problem D right here. We okay?
Go for it.
Right. Here we go. Question D. What do I have on question D? What are my bounds on question D?
3 to 6.
3 to 6. So which function? The last one, the g of x. Do I have a 3 to 6 over here?
No.
So how could I set that one up?
0 to 3.
3 to 6.
Well,
So it's kind of the same one as B. I'm going to go from 0 to 3, then I'm going to go from 3 to 6, and that's going to be the same thing as if I went from 0 to 6 the whole way. Okay? So it's basically like I have 3 variables, correct?
yes.
Do I know these? What do I know here?
You know 0 to 3 is -6.
Okay, 0 to 3 is -6. 0 to 6 is 10. So the one that I don't know in this case is this one right there, and that's what it's asking for. Okay? So if I were to solve this problem right here, if I simplified it into that equation, how would you solve that? Just add the 6. Add the 6. So this right here, that area is 16. Okay? Everybody okay with that? All right, here we go. Got 2 more. Got one that's on here, and then I'm going to make up one because I need to show you something else that they didn't include in this. All right? In this problem. Give you just a second to look at E. Kind of analyze it, see what you see. All right. So, what's a property that you see in this that would be helpful?
Taking the 3.
taking the 3 out. So there's a constant. So the first thing that we can do is we take the 3 out, and it would still be 2 to the 8. It would be g of x minus 2 dx. So the 3 would come out. So that's one of the properties. I have g of x, but none of these have a 2 and an 8 in them, do they?
No.
I need you to focus on this right here. What does this mean right here? What is g of x minus 2?
You're going
Isn't
to,
that y?
Move to the right.
or
I'm going to move to the right 2.
To the right too.
Okay?
any.
I'm moving right 2. And so if I were to do this right here, I'm just going to make up a shape. I don't know what it is, but I'm going to say, let's say that this is a triangle that's sitting right here. So this is 6, this is 0. Let's say that this shape, from 0 to 6, it says it's 10. So that's the picture there, all right? It says I'm going to take G, and I'm going to slide it to the right 2. So if I were to take this triangle, and I were to slide it to the right 2, then I'm no longer at a bound of 0 and 6. I'm at the bounds of 2 and 8. All right? So you see what happened there?
So this is still 0 to 6?
So it's basically still 0 to 6, but what did I do? I just moved it right 2. Did that change the area?
No.
It didn't change the area because my area is between that shape and the x-axis. So it stayed the same. So this right here is just another way of saying this. We've translated it. So it's worth 10 times the 3 on the outside. So this answer would be 30. Okay? Now, I'm going to do one last one with you real quick. All right. So this one right here, I'm going to say, all right, I'll raise that up so you can see that a little bit. So I'm going to go from 0 to 3, f of x plus 2 dx, and I want to find the value of it. Now, this is the one that's a little bit tricky. They left this off. I'm not sure why they left it off, but it's one that we need to talk about. Okay? All right. So what do you see in this one?
Seeing a plus 2.
Plus 2, which means what?
Up 2.
I'm going to move up 2. All right? And I see the 0 to 3, f of x, bless you, that matches this. So I know there's going to be a 5 as part of my answer as well. Okay? So here's the picture of this one. I like triangles, so I'm going to draw another triangle, sorry. All right? So if I did this, 0 to 3, all right? So that's 0 to 3. This is worth 5, all right? And what we're doing in this model is we're going to take this and we're going to move that up 2. Okay? So there's the new shape. Now, what's the difference here?
The area on the bottom, don't you need to fill
Okay.
all the way down?
I've got to fill this in because we're going now, we need this as well because we need the area underneath the curve all the way to the x-axis, all right? So there's like a little block that gets slid in here once we slid it up, all right? What are the values of that rectangle? 2 because we went moved up, and what? And by 3 because that's my boundary, my bound, 0 to 3. So the value of that box I've put in terms of area is 6. So this value right here would be the 5 that was stated up above plus the 6 that got slid in underneath. And so that would be 11 would be that final answer. Okay? So that's kind of the tricky one. When we're shifting them up and down, we're actually changing the area because we're adjusting it based off of the x-axis. Yes, sir.
Would there be another triangle there because it's not hitting the x-axis yet?
You talking about over here?
Yeah.
All right. Yes, but that's outside of my bounds. Okay, so if I change my bounds, then yeah, then I'd have to do a little bit more. Yes, absolutely. Okay. Any other questions there? All right. So I'm going to finish there. We've got about 16, 17 minutes left or whatever. So you work on page 449, I believe, is the next one on your bullet page. Should look very similar to what we just did there. And then if you missed a quiz, right now would be a great opportunity that you could get that knocked out.